All right, welcome to call number 5, fabric call number 5. May have a shorter call today as we had someone back out of the agenda. They had something urgent come up, but we'll get started with the update from Lynn on EIP 7917. And if you haven't heard Lynn and Justin's podcast with the ETH herders, would encourage everyone, if it doesn't inspire you, to make sure this EIP gets included in Fusaka. Not really sure what will. So with that, Lynn, it'd be great to get an update from you.
Yeah, quick update is that the EIP itself got CFI'd for Fusaka, which is gonna be a fork that's gonna happen later this year. But CFI meaning it's gonna be considered for inclusion, so it's not like what's called scheduled for inclusion, which is like confirmed. So it's just being considered. But I think it's the best that we could get at this point. But it also means that it's not confirmed that it's gonna be included. So yeah, exactly. It's pre-confirmed. So yeah, any like further support is always appreciated, like voicing your support for it and all that, it'll all help. And in the meantime, on my side, I'll just trying to add more tests to the specs and being sure that like the implementation progresses across the clients. But yeah, for now, I think it's good news that it's CFI'd.
Yeah, I'd like to reiterate one thing here that Len said. So the clients would really appreciate if an implementation for this EIP is done. PRs are open for an implementation. If they see that implementing this EIP is not going to slow them down from their primary goal of getting PeerDAS shipped, then including it will not be a problem, and the next DevNet will have it. And as soon as we have it in a DevNet and it works fine, then it will be slated for inclusion. So yeah, if you want to push it for inclusion as much as possible, if you can contribute to actually implementing it in the CL clients, go ahead and do it.
Sounds good. And is the main pushback just focus? Have we gotten everyone over the line on the concept? And are there additional concerns that have come up, or is it kind of the same? It's just focus of the hard fork versus anything else?
So yeah, like technically there's no pushback. I think everyone agrees that so far everyone thinks that the change itself is good, makes sense. Mainly the pushback is like in Fusaka, we wanted to focus on PeerDAS, and this is adding one thing to PeerDAS. It is a relatively small change, but still, like people are afraid that it diverges their focus.
One additional point that was raised is that this EIP is the only EIP that will actually change the state of the beacon chain, or change the schema of the state of the beacon chain, whereas the rest of the IPs that were slated wouldn't have changed the schema. But even with the change to the schema, thankfully, the proofs that the app layer depends on for the beacon block root will not have to, like that, the smart contracts will not have to change to generate these proofs. Sorry, to verify these proofs, because like a certain threshold wasn't crossed by adding this data to the state I don't know what to say, to the state schema, and therefore it shouldn't be a problem for dApp developers. But there was also discussion about the stable container for the state, etc. But that was declined for inclusion, so it's not going in. Or was it declined? I forgot. Len, do you remember what
Yeah, it was
was
declined.
Okay, so the
Yeah, it was
stable
declined.
container was declined. Okay. Yeah, so the stable container was declined, which is a major change to the state schema, right? And all the apps will actually need to upgrade. But afterwards, the stable container will help that any changes to the state schema will not require dApp developers to make changes to their smart contracts in the verification of proofs. Yeah, that's all. Sorry for rambling.
Yeah, and just one last one for me. So, talked about getting it implemented on the CL. Didn't Lighthouse and I think the consensus, I can't remember the consensus team's consensus layer client, but didn't they implement it or is it with the
So
other teams? Take you,
yeah,
yes.
oh, so Tickle implemented it. I didn't know that. But like as far as I know, Lighthouse implemented it. They said that it was a small change. And Prism have a draft PR opened, and they have some complaints that the change is relatively large because it touches beacon state. But yeah, like there's already a PR open. But yes, it's still in draft and it's not finished.
Okay. So drafted that plus the other CLs.
Yes.
Sounds good. Thank you, Lynn. Ahmed, thank you as well. And next, we'll have Jason talk about the constraints API. We just did a bit more work post the conversation last time where Justin had some ideas. So, Jason, over to you.
Great. So yeah, just quickly before that, some updates. So there's a new PR open for RAID, which was kind of the follow-up research on Ditto. And there's been some conversation with the Nethermind team and Tycho team on what that would look like in practice. There's a open PR for the commitment specs, but that's really meant to start discussion, and really we'll kind of dive into that discussion after this. And then on the URC side, sort of the big outstanding PR was merged that included some audit and optimization fixes, but Nethermind raised an issue that would make their lives a lot easier. So I think that's going to be a really easy one to add. So, but I think the next step with the URC really is to try and get running on a DevNet so we can get hands-on with it and see what other features we might want. So on the constraints API side, there's more detail outlined in that notion, but I'm going to try and cover it just at a high level here. But really, there was a lot of positive feedback over the last couple weeks. And for the people that weren't at the last call, basically there was this issue of fault attribution. Like, how do you make sure that like gateways are correctly punished if they're the one that like leads to a safety fault? And we don't want proposers to get slashed for things that they weren't responsible for. And during the last call, Justin kind of came up with an idea on the spot, and it seemed to be the best out of the 6 options, or became the 6th option. So the idea here is that gateways, they sign off on all the constraints that they want included in the block. Of course, like the gateway received this right once it was delegated to them from the proposer, but the proposer could always be the gateway if they don't delegate to someone else. But so the gateway, they're going to post these signed constraints, and the builders are going to sign off on them. So this is the signature B here. And this is them committing to building a block that satisfies the constraints. They include that signature when they post the block back to the relay, and the gateway is then responsible for signing over that header. And they can do this optimistically or pessimistically. The constraints API doesn't care. That's up to, I guess, relays preferences, or gateway relays and builders preferences. But if we just assume that it's optimistic, it could be as simple as the gateway calls this same get header with proofs, sign over. They want to sign over the header if they see a signature from the builder over the signed constraints. And then they replace the signature in the proofs from the header. And then the L1 proposer should only sign off on the header if they see a gateway signature. And that's what really protects them if there is a slashing challenge. And so this flowchart hopefully captures all of the different scenarios here. So let's say like a user, maybe their inclusion pre-conf was broken, like their transaction didn't land on the block. They can challenge at some slasher contract for that pre-conf protocol. And if the proposer isn't able to submit this gateway signature within some period, it kind of implies that they didn't propose the block that the gateway had signed off on. So that would be a safe default from the proposer, and they would be the one slashed. And then if we follow it down, well, if the proposer is able to supply a valid signature, it means that they just kind of forwarded along what the gateway gave them, and it should be like the gateway just gets slashed in this case. And it's sort of unclear at this point whether it's the gateway's fault or the builder's fault. The easiest thing to do is resolve this kind of off-chain with this flowchart, because builders are already going to be collateralized in the current PBS pipeline. But I mean, this doesn't have to happen off-chain. It just sort of adds more complexity to do it on-chain. But essentially, the gateway, if they, let's say, didn't provide any either any sign constraints, or they didn't provide valid sign constraints, and then the builder signs off on them, and then the gateway kind of signs off on their block, the gateway will be at fault. Like, the gateway has the full information that they either didn't provide constraints or they provided invalid constraints. And then if they still approve whatever they get from the builder, it's going to be their fault if the block is wrong. The more sort of nuanced one here is if the gateway provides valid constraints and the builder doesn't sign off on them, then the gateway proceeds to sign off on them. It's like the gateway just wasn't responsible there. Like, they shouldn't sign off on anything unless the builder kind of committed to the signed constraints. And then the last case here is like the builder committed to the constraints were valid, so the builder must have produced an invalid block, and in that case they're slashed. So maybe the nice part about this design, it adds one latency hop between the relay and the gateway. But even in a world where like gateways, relays, and builders all consolidate, they still can't do anything. Like, they can't collude with themselves to get the proposer slashed for something they weren't at fault for. So this design is kind of the most trustless in that sense. Yeah, I think we want to switch really to kick off the conversation on the commitments API. So I'd recommend, if there's like more questions or anything, to really check out the Notion link here.
Any questions? Yeah, concerns? I know we've been pinging people on the side, but if anyone wants to voice feedback or anything, happy to now. Great. And I think, yeah, the next step for this, plus the URC, is we are working on spinning up a DevNet across a couple parties, similar to Helder, but Helder's somewhat in a bad place because a lot of people register their validators but are offline. And so we're spinning a bit more of a robust setup since we've done this before, and we'll start testing this. And then once we get the commitments API, we'll plug that in, hopefully have the whole supply chain across the pre-comps and start working with multiple gateways to get that tested. So hoping to get that done probably in the next month and a half is what we're aiming for. All right. There's nothing else. Over to ETHGAS. I'm not sure who's presenting, but this is to kick off the commitments API conversation.
Cool. Hey, Drew. Kevin here. I guess, Calvin, are you around as well?
Yeah. Let me share the screen.
Yeah, maybe you can share your screen on your side. So, Drew, the month and a half, that's basically in line with Zuberlin, I guess. Is that right? I mean, do we have a conclusion there, I guess, on when we'll potentially be kind of getting together, actually?
Yeah, it's somewhat still deciding, I think.
Okay, that's fine. I don't want
Yeah.
to. Okay, just putting it out there. Okay. Okay, cool. So, Yeah, just so well, first off, sounds really exciting. It looks like a lot of the heavy lifting you guys have kind of like worked through on the calls and kind of async as well. So congrats, Jason and Drew on all this. I guess on our side, on the commitments, from the commitment perspective, just a quick recap for those who may not be familiar. It's basically with ETHGAS, you can buy inclusion pre-confirmations up to 64 slots in advance on L1. But there's other types of commitments we have as well, which may not be as relevant perhaps in the context of Fabric. But it's basically you could buy like the whole block, sequencing rights, inclusion pre-confirmations, and there's a discussion earlier about exclusion pre-confirmations as well. But it's quite extensible from one commitment type to another commitment type. In connection with this, there's kind of various steps that various steps and touch points where we integrate with basically the PBS pipeline. And from a high level perspective, we can kind of fully support, I think, kind of what's being presented, at least kind of previously. And so very excited to kind of get this moving. And if we can participate on the future DevNet, please let us know. We'd love to get involved there. That's all I really want to say on my side, but I guess Calvin, maybe I'll pass across to you to talk a bit more specifically about a couple things, perhaps in terms of like the signed responses and a bit on the payments part as well. So maybe Calvin, I'll pass across to you from here.
Yeah, sure. So this is our ETHGAS documentation. So we have some of the API integration example here. That will demonstrate part of the commitment API here. So so the user will try to log in through these two endpoints to get like a JWT token. Then they will get like a active market information through either through get the inclusion pre-conf market or the whole block market. Then the user can place the order either in the pre-conf market or the whole block market. Then they can get the order status, whether it's executed or still pending through these endpoints. Then on the fifth one, this is the one that will comply with the commitment API, which the user after they purchased the pre-conf on certain gas unit, then they can submit a bundle for this endpoint. And currently this endpoint doesn't return like a signed commitment yet. But in the future, we will add the signed commitment. Then the user can get those commitment, the signature from us. Then they can go to our stasher contract to present like a stashing challenge in the future. And lastly, they can retrieve all the submitted bundles from the user through this endpoint. And this flow currently, the user have to pre-fund to our contract first. They have to deposit ETH to our collateral contract first before they can start to trade. But I understand that for current commitment API, the user will they will try to pay the pre-conf tips through the priority fee, and because in our market the pre-conf price may fluctuate a lot, and if they pay it through like the priority fee, then they have to overpay first, then we'll refund that afterward. We will support that flow in the future, but currently we'll ask the user to first pre-fund the payment into our contract first before they can start to trade. That is a more efficient way to do it for the current approach. Yeah, that's all.
Yeah.
All
And I
my
think
side.
just adding to that, the basis for our marketplace is so that the prices can move or respond in real time. So coming back to what Calvin's saying, there's kind of two types of orders. One is a market order where I don't know exactly what the price is, but I kind of know approximately. The other is like a limit order, but yeah, it's just a matter of like what are the specific mechanics around it. It's probably more a logistical consideration, if anything, but whether we need to kind of whether this should be kind of pre-funded in advance, or we can get someone else to kind of fund it and take on some counterparty risk. We could probably figure it out. I don't think the magnitude of these fees is that significant that someone like we could probably just step in ourselves and just kind of like front some ETH just to make it kind of work a bit more seamless end to end. But a bit of the nuances we'll work through, but we can support it. So
Kevin, you just mentioned real time. So a question I had was around execution pre-comps. I think a lot of the discussion going back to the sequencing week was around the difficulty in doing L1 execution pre-comps and how a lot of them were constructed as like relative to the top of the L1 block. Is that, it sounds kind of harder to do that when you're talking about doing things in real time. So how does execution
Yeah,
precomp's work?
so the design space for execution precomps is so broad, and it's not really kind of composable from one type of execution precomp to another, in the sense that, like, if I wanted to do an execution precomp which was just like I wanted to just control like an Oracle updating, like that's not really composable with some like other components. So in terms of how we've designed it, we don't explicitly have an execution preconf. What we have is just a generic like sequencing preconf, or like a whole block market. And in that case, what happens is that you can basically, but we call it a whole block market. So you effectively buy a whole block of gas, 40 slots in advance. And you could, it's like an empty block of gas. You could basically buy it and sell it 2 seconds later. Alternatively, you can let time kind of roll down to now, and then you can build the block however you like. You've bought those sequencing rights. And so you could, in that case, you could take the top of the block, and you could include some, private and public order flow to fill the rest of the block. But in most cases, you're not going to have a lot of that private order flow. So then there's a third option where it's like, well, I just want top of block, and then I want to delegate the rest of the block to a builder. And then, you can put it out to a specific builder, you can put it out to an auction to a number of builders. But yeah, so we don't have a specific execution preconf, but effectively buying the sequencing rights kind of affords you the most flexibility. I think as time goes and we get more feedback, we might work on this a little bit further, but we don't want to kind of get ahead of ourselves where we're kind of stuck in some situation where we can't optimize for kind of the global max of the block value. And we have kind of these like fragmentation in terms of the product types.
Quick question, if that's all right. How do you see your API fitting in with the commitments API that's been put forward, especially with regards to lowest common denominator problems? So it looks like the commitments API is broadly targeted towards Bolt's API and doesn't really cover what you guys are doing and the nuance that you guys offer. It seems like from our implementation point of view, ETHGAS offers something extremely extensive and much more trader focused than just, hey, you can get a pre-conf basically.
Maybe Calvin, do you want to tackle that on the technical side?
Yeah. So I mean, we offer like more flexibility, but then for our core to submit the bundle, that endpoint will still compile with we shouldn't compile with the commitment API. And as I just mentioned, that we will also support like in the future for the user to pay the preconf tips through the priority fee. Then in that case, the user don't need to actually register in the ETHGAS in advance. Then they can just in the future there was a MetaMask lab, and then can QE like the latest market order, the market sale order from ETHGAS, then immediately feed the price, translate into like a priority fee. Then you can send the trade through this commitment endpoint to us. Then that trade can go through. Yeah, that's one path there.
Cool.
Well, actually, our endpoint like looks quite similar to the commitment endpoint, that we also have like a slot number here, and then they can specify transactions here. It's just like as in a JSON format or in a byte format. We can also support like the byte format in the commitment aspect as well.
Awesome. Any other questions? There's one team's implementation of a form of the commitments API. If not, next we'll have Ruben. Go ahead, Anthony.
I've got more comments
away.
about wallet integration and how the API is not going to meet that. So my biggest concern about the API and the way it's formed at the moment from the Fabric point of view is that there's no way to return state. And the only way you'll get integration from a wallet or from a dApp is to be able to is to return the state of what's going to happen after you apply the transaction, such that you can use it as a state override for like an approval or something like that, and pass it through to ETH call, and then trick the dApp or wallet into thinking that it's already happened. I think we should reduce the scope of what the API is targeting such that we don't include wallets, because I think it's just going to be a distraction. And realistically, the only people that are going to use these APIs are L2s looking for inclusion from a base wallet perspective, or perhaps sophisticated traders. But even then, I'm not so sure. So be keen to get people's feedback and opinion on whether or not we should just ditch the idea of trying to target wallets with this.
I have a couple of wallets actually that are looking at integrating. So, but they're not as fast moving, but they basically want that kind of fast response on their side. But maybe we come back to this a bit later.
Yeah, so the difficulty will be with the wallet can
Yeah.
offer, if you get the integration with the wallet, they'll be able to offer some sort of pre-confirmation to say, okay, you've done your approve, for instance. But as soon as you go back to the dApp, there'll be a disconnect with the state that the dApp sees, because they'll be talking to a different RPC provider. So there's no way to currently push for to tell the dApp to say, hey, go and get the state from over here because I've got a pre-confirmation. Yeah, realistically, you would need to get buy-in and adoption from all dApps first, or Infura, basically.
Good. I don't know if we have strong views, but we can, yeah, we're absolutely open to exploring this. Yeah. So we still haven't finalized the commitments API. We're just hoping to kick off the conversation, get that going. And I know you guys are working on some stuff too that we definitely want to take into account and think about when you're ready.
The only other comment on that side of things would be if you are looking for wallet integration and that side of things, you should probably trend towards JSON RPC and stick with that rather than switching to a sort of REST-ish API. It's the sort of thing somebody might get hung up on.
Awesome. Yeah, and there's one team, Gattaca, that's done a bit of work on this, I think, with some wallets, and they're just not on today. So they may have some view or some way around this. But next time we'll have them make sure they chat about what they did.
Was that for the Tycho stuff? Who did you say? So Gattaca?
Gattaca, yeah.
Yeah, so yeah, they tricked the JSON RPC into behaving. So the pre-conf would do like a sort of virtual block, and then you fork. So you could, well, depends on the wallet. So with MetaMask, you need to trick it into thinking that a block has been mined, and then it will go and look for the receipt of the transaction that you've posted, and then it'll recover if you've, in a sense, in essence, fork. The other option is you just return a transaction receipt and put some dummy values into the transaction receipt.
Got it. Awesome. So good. Yeah, teams run into issues. Where Antini is. I'm sure he's happy to collaborate with you all, and we'll keep this conversation going. Yeah, one other team that's worked quite a bit on this is Lubin, and they're going to present what they've done, I think, mostly with Rise, if I'm not mistaken, and some implementations there, but just overall how they approached it and their thinking. And I don't know who's presenting. I think it's Stanley,
Yeah,
but
sounds good. Yeah, I'm gonna do it. Let me share my screen. All right, you can see it.
not yet.
Maybe no. All right.
Now
So
I can see
good.
it. Yep.
Yeah, so hey everyone, I'm Stanley. I'm from Luban. Also have my our team member Shirok here, who's going to cover the more technical part. Today, I just want to briefly talk about how we configure our commitment API in the context of base rollups. Basically, I think a lot of you probably know us as a pre-conf team, and that's correct. But I'll say from day one, we haven't been building a regular pre-conf. The goal has always been to provide both certainty of inclusion, of future inclusion, and the cost lock-in, meaning we want users to to pay a fixed, predetermined price for a future slot in the future block. And second, we want the pre-conf to be fungible, meaning we don't want that pre-conf to be tied to any specific transactions. Instead, we want it to be basically empty block space or just pure gas that can be resold to others. So to build this type of fungible inclusion pre-conf, obviously there are problems. So first, so to lock in the cost beforehand means the gas seller, aka validators, they will need to bear the pricing risk of the gas, right? They could undercharge for future gas, meaning they could lose money. And obviously validators don't want to lose money. And second, fungibility in pre-conf means the transaction data actually lacks the pre-conf request. Means a user can request a pre-conf and get one before he or she actually sends the call data to the pre-confer or the gateway. And that results in multiple rounds of communication between the user and the gateway, and also there's a exchange problem.
For noon.
Right. So, and there's a fair exchange problem. Means a user could just intentionally withhold the transaction call data, and not sending that to the gateway, and the gateway without the data cannot really fulfill the commitment, which could actually slash the gateways. So obviously we have to solve these problems, and the solution is basically the first we insert a gateway into the system as a middleman between validators and users, and the gateways, they will absorb the price risk, meaning they get delegation from validators, and they still pay the gas needed when the slot actually comes, and the gateway will sell pre-conf to users beforehand, and if the gateway underprice the pre-conf, and the gateways will just eat the loss, and the validators will still be made whole. And second, to address fair exchange problem arise from fungibility, we designed a game theoretic payment scheme using repeated games to just discourage unfair exchange. More on this later. And the first use case of our fungible inclusion pre-conf is for blobs. Like Drew said, we've been building with Rise for a while about blob futures. Basically, right now, especially for smaller rollups, they're facing both uncertainty in frequency and cost of blobs. So, as you may know, builders, they tend to include less blobs than local builders because blobs are bigger, and they create higher latency in block transmission. So and also there's a 6 maximum blobs per block, and also the cost can change like a lot because of the imperfect 444 algorithm, I'll say. So, and our solution to this is to enable rollups to purchase future blobs at a predetermined price. So, as a rollup, you just buy blobs from a future slot, and then you pay now, basically. And the flow is pretty simple. So first, the validator will need to delegate the blob space of his slot N to a gateway, and we call them underwriter in this scenario because they're underwriting blob futures. And then the rollup will negotiate with the underwriter in an RFQ model and to agree on a price to pay for future blobs in the slot N. And then the underwriter before or at slot 10 will receive the rollup batches from the rollups, and then will enforce blob inclusion using the pre-bought blobs in slot 10 via the constraints API. So I'll say it's a pretty straightforward process. And at the end of the slides, you will see the implementation done by Rice, also the clients and everything. Actually, we have been also experimenting this with Spire as well. So yeah, like obviously block futures it addresses DA, but for us we want to support the full lifecycle for rollups. So we're starting with DA, and we have a 2 epoch look ahead. So we're starting from here. But in the future, we're going to support basically all features that rollup needs, meaning, let's say for DK rollups, it's going to be proof verification. And then we move on to just arbitrary regular transactions, and they will all exist in the form of futures. So like you buy now, you pay you pay a predetermined price. Also on the x-axis, it's called expiration. But basically, it means how far into the future you can purchase these futures. Right now it's 2 epochs because we have a look ahead of 2 epochs, roughly 12.6 minutes. But we want the underwriters to be more powerful. So like these underwriters, they can be very flexible. Right now they're guaranteeing their like their own rights for inclusion by delegation from validators. But actually they can just do more like financial stuff on their end. They can do their own hedging, their own modeling, so that they can provide a longer expiration product to users. Let's say they can provide like daily futures or like weekly futures to users. Meaning at a rollup, you can just pay every week for everything that you will do on the layer 1. DA, settlement, proof of verification, anything. So your price will be fixed on a weekly basis, and all the risks will be absorbed by the underwriters. So basically, the end game will be settlement as a service. So we want to cover everything a rollup will need, with this this form of service, with this future service, with a longer expiration. So here's the an overview of the user flow for block futures and how the API is utilized. And actually, more than block futures, like basically everything we do in the future will also follow the same process. Basically, the validator delegates first to the underwriter, and then the user will send a request to the underwriter, and the underwriter will sign the commitment and then collect payment. So that's like before the target slot, obviously, because it's pre-conf. And at target slot, there are two scenarios. The first scenario is the user, supplies the transaction call data to the underwriter, or the rollups, actually send the batches to the underwriter, and then the underwriter will just submit transaction to to the relay and then enforce inclusion. But there's also a scenario, where the user fails to send call data to the underwriter, so that the underwriter doesn't have anything to include. So in this case, the underwriter will call a exhaust function in the loop and smart contract to just exhaust this commitment, so that there's no duty to be fulfilled. And also, he will also submit this transaction calling the exhaust function to the relay. So there's a basically this is the payment design is our current way to solve the fair exchange problem. Basically, the payment from users is split between into pre and after payments. So the underwriter only gets the prepayment when he signs the commitment, but he only gets the after payment after the inclusion is made into the block. So if the underwriter actually calls the exhaust function and then basically abandons this duty, he will not be able to collect the after payment from the users. And obviously, in this way, with repeated games, we expect underwriters to behave responsibly, and also for the users to behave responsibly to deter any sort of grievance to each other. And then finally, there are some common steps. So after the transaction constraints submitted to the relay will broadcast constraints to the builder, and then the builder will build blocks with the constraints, and then the relay will just follow the PBS pipeline to this shared high speed and then propose. Yeah, so here's the high level overview, and then I want to just pass it on to Chirag on the some details of the commitment API.
Yep. Thanks, Stanley. I will just quickly go through the commitment APIs. So yeah, these are the APIs that we offer. So first API is a get method to fetch the available slots for reconfirmation in the current lookahead. And yeah, I think the first two are the standard ones. The second one is to fetch the fees made to pay for that reconfirmation of for a particular slot. And yeah, the next API is for submitting pre-conf transactions without reserving block space for that target slot. We call these type of pre-conf request as type A request. So, and the other type is the type B request, in which the yeah, could you just show the previous slide? Yeah, this one. So for the type B request, a user must reserve block spaces in advance for the target slot, and later when the slot arrives, he must submit the pre-conf transactions before the slot deadline. Yeah, the next slide, please. Yeah, so the major difference between the type A and type B requests are type A is basically non-fungible and type B is fungible. The ability to reserve block space in advance, that is, the commitment is not attached to those specific transactions. It makes the type B request fungible, which Stanley talked about in his first slide. And also they differ in the tip payment. For type A requests, the user must include a e-transfer transactions along with his pre-conf transactions. And for type B, the user must deposit a specific amount in a escrow contract so that the gateway or the underwriter can claim it fees later. Yeah, the type A is meant for general purpose, and type B is specifically for rollups. Next slide, please. Yeah. So these are the useful links. And also the Golang client that Rise used for the POC that we performed. And yeah, also the examples for our APIs. So what do you, Stanley?
Yeah, that's all from our side.
Awesome, thank you. I was curious if the underwriter, or if you see any issues of compatibility with the underwriter and like what I had showed earlier on the slide with builder, relay, builder, gateway, proposer interactions.
I assume you shouldn't, because I think in the in our context, the underwriter is basically the gateway, right? So I think and the rest of the flow should just follow what you mentioned. So I think it should be compatible. Yeah.
Awesome. Thank you, Lubin team. Any other questions? All right, we'll be back on the constraints API in URC DevNet. Just need a little bit of time to work through this. And then the commitments API, I think the one team we're somewhat waiting for more feedback around is Spire, and fortunately we have a MetaMask guru that's helping on that. And so we've got some spec outlines, but we'll probably keep adjusting that a bit. Yeah, former MetaMask guru. And so hopefully in the next month or so, we'll get to a good place on the commitments API. But from what we understand, about 95% of what's there, most of the teams are using, and we'll make sure to flag anything that changes significantly. With that, that's all we had on the agenda. We'll probably do 2 weeks out unless something urgent comes up, and we'll have the gateways back on. Thank you all.
Thanks.
Thank you.
Thanks.